Let's do alkenes, please. Let's do alkenes. Alkenes are hydrocarbon with the, do this, C double bonded to C. This thing means carbon-carbon, please. This thing means carbon-carbon. With the, this double bond, with the, this. This is red, carbon-carbon double bond, please. Alkenes are hydrocarbons with the, this. This is red, carbon-carbon double bond. What's red? With the carbon-carbon double bonds, and have the general formula CnH2n. And have the general formula CnH2n. Full stop. This man, please, is it saturated or unsaturated? Take down, please. These unsaturated hydrocarbons, are these, These, these. These unsaturated hydrocarbons are isomeric, that means they're isomers, are isomeric in brackets, have the same molecular formula. Close the bracket. With the saturated cycloalkanes. With the saturated cycloalkanes. We discussed this one earlier, Abby. What we said, alkenes are what there? Cycloalkanes are what there? Isomers. What kind of isomers? Functional isomers. So if you're here earlier, we talked about it for now. All right. Note, or before the note, please. Let me just express that point again. I said alkenes and cycloalkanes are isomers. Let me take an alkene. Let me say but1ene or butene. For but, I expect 4 carbon. 1, 2, 3, 4. This. Balance it up. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is but1ene. I'll tell you why the 1 is there. Let's look at this. But1ene is 1, 2, 3, 4. C4, 1, 2, 3, 4, 5, 6, 7, 8. H8. It still satisfies this formula. Cn, when n is 4, it becomes H into 2 times 4, 8. This one here is an isomer of a cyclobutane. 1, 2, 3, 4. So this is cyclobutane. Balance it up. 1, 2, I have 3, I have 4. 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 It's a cyclo compound. Why? It's in ring form. This becomes cyclo number 2. I have 4 carbon atoms. That becomes a but. Number 3 is single bonded throughout. That's an alkane. So cyclobutane. What I have here is 1, 2, 3, 4, C4, 4 carbon. I have 2, 4, 6, 8. So observe that the cycloalkanes are isomers of their corresponding alkene. So please take note. That means an isomer of propene is cyclopropane. An isomer of octene or oct1ene is cyclooctane. That's the idea. All right. Note. The first member of the alkene group, or alkene. The first member of the alkene group is ethene. is this is ethene. So the first member of the alkene is ethene, comma, put it in quotes. In quotes, methane does not exist. Please note that methane does not exist. Methane exists. Methane does not exist. How? Use the formula there. The formula is CnH2n. For a met, C is 1. So it becomes C1, that's perhaps C, H into 2 times 1, 2. So let's say I have carbon H2. How? H and H. This is not balanced. In other words, methane does not exist. But then methane exists. Put this as 2. I have C2, N as 2. H into 2 times 2 is 4. So I have carbon, carbon, C2. Since it's an ene, I'll have a double bond. This one has 1, 2, 3, 4 balanced. 1, 2, 3, 4 balanced. C2H4. So the first member of the alkene group is ethene, not methane. All right. Take down, something to note, 1 line space paragraph, 1 line space paragraph, 1 line space paragraph. Although the double bond is a stronger bond, although the double bond is a stronger bond than a single bond, yet the, write this one down, carbon-carbon double bond, yet the, write this one down, carbon-carbon double bond is much more reactive, than this carbon-carbon right there, single bond. As I said, the carbon-carbon double bond is much more reactive than C, just one. This red carbon-carbon single bond. Much more reactive than the carbon-carbon single bond. Let's look at the nomenclature of alkenes. How to name alkene compounds. Nomenclature of alkenes. All right, let's do nomenclature of alkenes. Please, the rule when it comes to alkenes changes. When we did naming of compounds, it was always an alkene. There's a reason why we did that. When it comes to alkene, the rule changes. Well, the rule remains the same. It is the priority that changes. Take down, please. When it comes to naming the alkenes, take down. When it comes to naming the alkenes, priority is given to the position of the double bond, not necessarily the substituent attached. Very important. When it comes to naming the alkenes, priority is given to the position of the double bond, not necessarily the substituent attached. So look up, let me show what I mean. Not necessarily the substituent attached. So put a full stop there and then look up again. Not necessarily the substituent attached. Put a full stop and let's proceed again. Continue, please. Add there. The position of this double bond is indicated using numbers. The position of this double bond is indicated using numbers. Using numbers. Example. Example, please look at this compound, observe carefully. Now listen. Normally, if this was to be my alkane naming, I would start from here because I have bromine. It will be this way. But when it comes to alkene, please, my focus on my priority is what there? The double bond. So when it comes to alkene, start from the part or from the way that will give you the lowest number to the double bond. In other words, if I go this way, I'll have 1, 2. 2 for bromine, 3, 4. 4 for double bond. If I go this way, I'll be having 1 before the double bond, 2, 3, 4, 4 for bromine. Please, my priority is the what? Double bond. So I'll number it in such a way that the position of double bond becomes the smallest, which will be this way: 1, 2, 3, 4, 5. Why? I want the smallest number for my double bond. In other words, the number of this compound becomes from here to here 4 bromo. 5 is what? Pent. I said show the position of the double bond using numbers. This one is attached to compound what there? 1 in. So it's called 4 bromo pent 1 in, or 4 bromo 1 pentene. So I have this. So that's the name, please. 4 bromo pent 1 in, or 4 bromo 1 pentene. See the way I play with the numbers. See why I play with the numbers. Please complete the structure on your own, please, and give the name, please. Complete the structure on your own and give the name, please. Let's get this done. Hold on. So, it's okay. First task, complete the structure. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. How do you number this? Number it in such a way that the smallest number should be attached to the carbon bearing the double bond. The double bond is the priority over other substituents. If I start from right to left, I'm numbering 1, 2, 3, is carbon 4 that bears the double bond. If I start from left to right, I'm having 1, 2, 3. It's carbon 3 that bears double bond. Between 4 and 3, the smallest there is 3. Hence, I'll number this way. So 1, 2, 3, 4, 5, 6, 7. So I have this. All right. Having said that, what next? My substituents here, bromine, chlorine, iodine. I will take them according to alphabetical order. So B first. That becomes what there? 6 bromo, 2 chloro, 5 iodo, 7 is hept. 3 in, or what's that? Or 6 bromo, 2 chloro, 5 iodo, 3 heptene. So I said always observe the way we play with these numbers. Take the number in between the stuff and the in, or before any of them. So I have this. Let's try one more example before we move on, please. One more example before we move on, please. All right, copy this down, complete it, and give the naming, please. Copy this down, complete it, and give the naming, please. Copy this down, complete it, and give the naming, please. So let's get this done. First is first, complete the structure. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Complete. 1, 2, 3, 4. Complete. 1, 2, 3. One more. 4. 1, 2, 3, 4. So I have this. All right. Having done that, observe something. Observe that if I count from left to right, I would have 1, 2, 3, 4. The fourth carbon bears double bond. If I count from right to left, 1, 2, 3, 4. The same fourth carbon bears the double bond. In a case where from both sides is 4 and 4, that means double bond is no longer what there, the priority. You now focus on the substituent. That's the idea. So if I now focus on the substituent there, from here, of course, I'll get the smallest number to bromine. So in other words, I'll now count 1, 2, 3, 4, 5, 6, 7, 8. What I am stressing here is this. Don't go and say both sides are equal. So let me just count from here. The same thing. It's not the same thing. In a case where it's 4 and 4, focus on the substituents there. That's the idea. All right. So name is what you get there. Starting from the inorganic, that's your halogens. Bromine, what up there? So 2, 3, what there? Dibromo. 4 chloro. 3, 6. 3, 6. Dimethyl. Methyl what? Hold on. That becomes oct. 8 is oct. Oct what there? Oct 4 in. Or 2, 3 dibromo, 4 chloro, 3, 6 dimethyl, 4 octene. All right, so that's the idea there, please. That's the idea, please. Look up, please. Next up, please. Let's look at some special nomenclature. Let's look at some special nomenclature of alkenes. The first set of special nomenclature we'll consider is the cis-trans system, cis and trans system of naming alkenes. That's from the concept of what there? Geometric isomerism, which we did last time. All right, just do some few examples and move on, please. So, I told you, look at this, look at this, please. All right, so look up, please. Look up, look up, look up. So, easy to get. Listen up. Easy to get. I said, in a case where, depending on what you want to focus on, whether the alkyl groups or the hydrogen, if they are like this, I said the idea is simple. Trace them. If I trace this, is forming this core. That's what there is cis. So it becomes cis. Cis what? Now hang on. How do you get the next thing there? I have 2 carbon here. So 2, this one here, 3, this one here, 4, this one here, 5. In total, I have 5 carbon atoms here. In total, 2, 3, 4, 5. 5 is what there? A pent. So 6 pent, pent what? My next step, I will ask myself, where do I count from to get the least number to double bond? If I count from here, this 2 carbon here, so carbon 1, 2, and then what again there? 3. Carbon 1, 2, 3 before double bond. If I count from here, I have just 1 carbon here, so carbon 1, 2 before double bond. Counting this way, I'll count 3 carbons before double bond. Counting this way, I'll count 1, 2 before double bond. So I'm using what there? The least, which is what there? 2. 6 pent, 2 in. That's simple. In a case like this, where I say they are at opposite ends, it becomes what there? A trans. Right? Here and here, opposite. Trans. I said if you follow it, form a T, as we did in the previous class, it becomes trans. Trans what? Count total carbon atom. 2, 1, 2, 3, 4, 4 plus 3. How many there? 7. 7 is what there? Hept. So trans hept. Hept what? Which of them gives you the smallest number to your double bond? This is 3 plus 1, 4 to double bond. This is 2 plus 1, 3. Between 4 and 3, 3 is the smallest. 6 have 3 in. Trans have 3 in. So this is how you name this one. Let's move on, please. Question. Okay, so listen up, please. He's saying from your text, this man comes to a hyphen, something like this: cis hyphen pent 2 in, like this. All right, so if that's what's there, then no problem. You can feel free to use that one. So to small letter 2, small letter 2, that's trans hept 3 in this. Well, okay, no problem. But I don't think it's a major problem there. You already know how it looks like. So if your text says it's like this, there are no problems. Just do it there. It's not a major problem. At least you know how it's named. Just put hyphen, use small letter. That's all. Let's look at the next special case called the easy nomenclature of alkenes. So look at the next concept there. Easy nomenclature. So listen up, please. Listen up, listen up, listen up. We'll keep the same examples and use them as a reference for our next special nomenclature. The next special nomenclature is called the easy nomenclature. E and Z. E and Z. Nomenclature. All of you want I wrote easy. Not easy, oh. I mean E and Z nomenclature. So easy nomenclature, please. Let's look at this. Think down, please. The E and Z nomenclature can be used in place of the E and Z nomenclature can be used in place of the trans and cis. The trans and cis system. The trans and cis system. The trans and cis system respectively. The trans and cis system respectively when an alkene does not bear two identical groups. When an alkene does not bear two identical groups. Does not bear two identical groups. All right. So I said E and Z. E, Z. I said can be used for which and which respectively? Trans and so E is for trans, Z is for cis. That's the first one to show you here. E is for trans, Z is for cis. Now listen. Listen, please. Listen, please. When we did cis-trans system, we had two alkyl groups at this position, and here was hydrogen, hydrogen. What of a case where we now have three alkyl groups? Of course, it's no longer cis and trans. It now becomes the easy nomenclature. How do you use easy nomenclature to name this? Look up, please. That's how it works. That's how it works, please. First things first. Follow my rule 1, longest continuous carbon chain. It's either I'll go the cis way. For cis way, it's like this, as we know. This cis. For trans way, it's like this. Obviously, my longest continuous carbon chain is starting from here to this point here. Because in total, I have 2, 3, 4, 4 plus 3. How many there? 7. So this one becomes my longest continuous carbon chain. So if I have this one here as my longest continuous carbon chain, and we say is 7. 7 is what? Hept. Of course, functional group, double bond is what there? Alkene. This one here now becomes what there? Is substituent. But then it's a special kind of substituent. So since on a normal, this should be my what there? Trans system. For a trans system, the equivalent of trans in the easy system is E. In other words, this one here, the name becomes E. Okay, now listen please. Then becomes E. So see the way I write this please. E in brackets. Next up, I want to write methyl. But of course, I have to show the position of methyl. Listen and listen carefully. I want to write methyl, but I will show the position of methyl. But of course, this is again an alkene. And in my alkene, we said my priority is what there? The double bond. So where am I numbering from? Is it from A to B or from B to A? It has to be A to B. Because from A to B, I'll have the smaller number to double bond. From A to B like this, I have 1, 2, 3. It's carbon 3 that bears double bond. From B to A, I have 3, 4. The smaller one is A to B. So I'm having 1, 2, 3, 4, 5, 6, 7. Please. 1, 2, 3, 4, 5, 6, 7. So this now becomes E because E is the trans equivalent. So E, this one here, 4, the substituent there, methyl. So E for methyl, 7 is what's there? Hept what? Hept what? Hept 3 in. That's how you name this. Now relax, relax. Let's go back this again and then we are done. Relax. Let's see something here. Please confirm this is correct. Confirm this is correct. See if page 11 is correct. All right. Let's name this one here. Look up, please. Obviously, longest continuous carbon chain has to be this one here. This one here. And this is what there is cis system. Abi? If it's cis, what will be the corresponding E or Z? So it becomes Z. My substituent, this one here, what is this? Ethyl. So the question now is this: where do I take my numbering? Call here A, call here B. Am I numbering from A to B or B to A? Or A to B, of course, because this is 3 plus 1, 4. That's your shortest. So I'm having 3, 4, 5 plus what there? Okay, hold on. How many carbon in total? 10. 10 is what? Is deck. That's row 1. Row 2, functional group, double bond, alkene. Alright, so let's play with this. So I'm having Z, which is the cis equivalent. This one becomes what's it called? The substituent. That's ethyl. Ethyl is attached to which of the carbon there? Carbon 5, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how it's done. So it becomes Z5 ethyl. Ethyl what there? Deck what? Not decino. Deck 4 in. Or you can call it Z5 ethyl 4 decene. How do you call this? It's decene now. Decene. What do you call this? Decane. What do you call this? Decane or decene? Decene. What do you call this? Okay, so it's called decene, right? Sorry, this is called decene, right? Yes. I don't know why if it's decene. If this is Beck, it's called Becky, not Bessie. Becky. So Beck, deck, decene. Right. So it's called decene. All right. So decene. Okay. E5 ethyl deck 5 in, please. That's the name. All right. Moving on, please. All right, so let's consider preparation of alkenes. Please take down, please. The methods for the preparation of alkenes includes number one, hydrogenation of alkynes. Hydrogenation of alkynes. We've said when we say hydrogenation, it means I'm doing what there? Adding hydrogen. Take down, please. The hydrogenation of an alkyne, results in the production of a corresponding alkene. The hydrogenation of alkyne results in the formation of a corresponding alkene of an alkyne results in the production of a corresponding alkene. By corresponding, I mean the same number of carbons. But like corresponding. Example, so here's the equation of the reaction. Of course, this one represents an alkyne. So alkyne plus hydrogen gives you alkene. So example, let's take N to be 2. If I take N to be 2, becomes C2. So C2H into 2 times 2, 4 minus 2, 2. So C2H2 plus H2 gives you, we said N is 2. It becomes C2H into 2 times 2 is 4. What you have here is ethyne. So an alkyne plus hydrogen gives you an alkyne, ethyne plus hydrogen gives an alkene. That's 18. So I have this. Sorry? No. So I have this. Let's try to draw the structure. For this one here, C2, so I'm having C1, 2 is an alkyne. For an alkyne, I expect what there? A triple bond. So it becomes 1, 2, 3. This one to H. 1, 2, 3, 4. Balance. 1, 2, 3. This one to H. So I'm having C2H2. That's this. Plus H2. So plus H2 to give you C2H4. C2, 1, 2. Being an alkene means it has a double bond. Balance up. This one has 1, 2, 3, and 4. 1, 2, 3, and 4. So this becomes the structural formula. Ethyne combines with hydrogen to give you ethene. So that's the first preparation of alkyne. All right, number 2 method of preparing alkenes. Now listen and listen carefully. If they ask you for preparation, bear this in mind. If I want to prepare alkene, I will have to do hydrogenation of what there? Alkene. If I want to prepare alkene, I'll do what there? Of what? Alkyne. Yeah, that is simple. If I see, alkane is double bond, alkene is alkane is single bond, alkene is double bond, alkyne is triple bond there. The idea is this: if I hydrogenate a double bond, it will break up this bond to give you an alkane. That's the concept. Also, if I hydrogenate an alkyne, 1, 2, 3, it will break off one bond to give you what there? An alkene. So please don't forget this, please. Number 2 method of preparing alkenes, number 2, is by the hydrohalogenation. The hydrohalogenation of alkyl halides. Take down, please. The general formula for this reaction is given below. Quite a lengthy one. The general formula for this reaction is given below. All right, it's given as this. So you have this, where R is an alkyl group, an alkyl group member. X is what there? A halogen. All right, so I have this. X a halogen, and I have that one as an alkyl member. You have this. Are we done, please? Take down, please. The ease, E-A-S-E, easy, ease. The ease of the hydrohalogenation of alkyl halide. The ease of the hydrohalogenation of alkyl halide is given by this one is called a tertiary alcohol, secondary alcohol, primary alcohol. We'll discuss what they mean in our next class when we treat alcohol. But keep it pending, please. Now, what this means is this, that it is easier for a tertiary alcohol to dehydrohalogenate an alkyl halide than a secondary, than a primary. So the most, so which one do I do there? The alcohol that has the greater potential or power to dehydrohalogenate an alkyl halide is a tertiary. The one with the least power is what there? A primary. That's the idea. All right, take that, please. Example under this, please. Example under this, please. Let's take R. Let's take R. I'm taking R now as butyl. I'm taking X as chlorine. R as butyl, X as chlorine, please. On your own, please, try to sketch out the formula. See what you get, please. On your own, please, try to sketch out the formula and see what you get, please. Take R as butyl, take X as chlorine. Get out the correct structure and name each of the compounds there. And name each of the compounds there. Give it 2 minutes. 2 minutes. Take this as a butyl. Take this as chlorine. Draw the complete structure. When you're done, name each of them, like each of the terms there. All right, so look up, please. Look up, please. So for this one first, I'm having this as CH3 from here. 1, 2, 3 into CH2. C1, 2 into CH2, C1, 2 into CH, C, we said X will be attached to this, so ClHH. Is that okay? Yeah, so I'm having CH3, CH2, CH2, CH. Now it was CH first for butyl. That's CH2, and we said X, that's your chlorine, I have this, plus KOH, so KOH, passing through alcohol, to give you this one here. Now, hold on, look up, please, hold on. What we should expect here would be, look up, please, although this is an alkyl, don't forget, we are trying to do what there? Prepare what? An alkene. So to be the alkene of this, that means something of this nature. C2, I have 4 here. 1, 2, 3, 4. So 1, 2, 3, 4. Please add a double bond. That's this, please, because I'm trying to prepare an alkene. So if I combine, I'm having 1, 2, 3. 1, 2, 3 combines with this 1, 2. This one I'm having 1, 2, 3. One more, and then 1, 2, 3, and 4. So I have this one here. This plus k, that's x, or k there, and then x is what there? Cl plus what there? H2O. So I should have something of this nature. So if you check this, look up please. If you check this, everything here is balanced. 1, 2, 3, 4. 4 carbon. I'm having 1, 2, 3, 4. 4 carbon. Look at hydrogen. I'm having in total here. I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9. This one here, 10. Here I'm having product side. I'm having 1, 2, 3, 4, 5, 6, 7. Where? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So hydrogen is also balanced. Look at potassium, K balance, chlorine, Cl balance, oxygen O1, O they're balanced. So it's correct. So please just take note that it will be what there? A double bond there. So I'm having this. How do you name this? What do you call this? One or what? Or what? So listen, please. What do you call this one here? Now listen. I discussed this stuff in the last class. I said this stuff here can be pronounced as either what there, an alkyl halide, or what there, haloalkane. As an look up please. As an alkyl halide, it means call the alkyl group before the halogen. In this case here, the alkyl group was what there? Butyl. So as an alkyl halide, this one is called butyl, and then the halide, chloride. So I have this. Or call it a haloalkane. And I said for haloalkane, I'm calling the halogen first before the alkane. If I call the halogen first, halo, chloro, that's it. So it becomes chloro, what's there? Butane. That's the name. Or better still, 1-chlorobutane. By adding 1-chlorobutane, I am showing that the chlorine is attached to what there? Carbon 1. So 1-chlorobutane. That's the name. What do you have here? Potassium hydroxide. What do you have here? Don't tell me butane. What do you have here? 1-butane. Or what there? But-1-ene. What do you have here? This one here. So please just be observant. That's all. Be observant. That's all. Third method of preparing alkenes is dehydration of alcohol. All right. The dehydration of alcohols using acids result in the production of an alkene and water. Result in the production of an alkene and water. Result in the production of an alkene and water. Equation of reaction is given below. So you have this. Equation of reaction is given below. You have this. You have this. So an alcohol, acid, an alkene, and water. So you have this, please. Your first task, please. Please complete the structure, put H when necessary, and name each of the compounds there, please. For this, put H when necessary and name the compound, please. What do you have? Put H for each of these and name the compound. What do you have? That should be all there. Ethanol. Please, OH is the alkanol. So having two carbon is et. That's ethanol. So ethanol undergoes dehydration using acid to give you what there? It's in and what there? Water. Let me use the prop. If I use prop is 3 carbons. I'm having 1, 2, 3. This one is prop. For it to be a propanol, there has to be an OH. So I'll attach OH here, and then perhaps complete the structure. I'm having 1, 2, 3, and then 4. 1, 2, 3, and then 4. 1, 2, 3, 4. This one here is what there? Okay, so acids, or use an acid there to give you a prop, will give you a propene. So I'm having 1, 2, 3. Put my double bond, of course, for the alkene. Put single bond, complete the structure. I'm having 1, 2, 3, 4. Balanced. 1, 2, 3, 4. Balanced. 1, 2, 3, 4. Balanced. Plus H2O. So this is an example. What I have here is propan 1 oil. All right. Now we'll talk about this one too. I've not taught you alcohol. I'll check alcohol here, please. This one here is not just a propanol. In the propanol or in the alkanol, you have to indicate the position of the OH group. For this one here, if I count from left to right, I have 1, 2, 3. If I count from right to left, I have 1, 2, 3. So if I count from right to left there, it means that the OH is attached to carbon 1. So hence, propan 1 oil or 1 propanol. That's the idea. So what do you have here? Prop 1 in. Or what's there? 1 propene plus water. So I have this. Listen. It is useless to say 1 ethene. Why? There can be no 2 ethene. Ethene is this. Look up. For ethene is double carbon 1, 2. Like this. If I come from left to right, it's 1 before this. If I come from, that's from right to left. If I come from left to right, it's still 1 before this. So whichever way, it will always be what there? 1 ethene. So even if you say just ethene, it's still okay. I think same thing with propene itself. Same thing with propene. There is no 2 propene. Can there be 2 propene? Look at this, look at this, look at this. 1, 2, 3. This one gives you a prop. Let us say we want to put double bond here. That becomes 1 before this one here. So it's prop 1 in or 1 propene. What if I choose to move it here? Will it become 2? No. It will still be 1. Why? Because I will now have to what there? Count from this side this way. So I say about there 1. In other words, there is no prop 2 in. So if you want to say just prop in, it's okay. Because prop 2 in does not exist. So you can leave out the 1 and just say propene. It's correct. There is no 2 propene. Yes. No. At this level, no. Number 4, please. Number 4, please. The halogenation of vicinal dihalides. The halogenation of vicinal dihalides. Equation of the reaction is given below. Equation of the reaction is given below. Is given below. So you have this. Please do me a favor, please. Take X as equal to bromine Okay, put H, complete the structure and name each of the compounds. Take X as being bromine, put H, complete the structure and name the compound, please. What do you have? Now listen, listen. If I choose to make each of these points H, I'll be having H here, H here, H here, Br here, Br. This compound what there? 1,2 dibromo what there? Ethane. 1,2 dibromo ethane. What will be here? 18. Let's use a boot. Let's use a boot. So if I'm using boot is 4 carbon. So from here I'm having 1, 2, 3, perhaps. Okay, let me make it smaller, please. Let me use boot there. 4 carbon. 1, 2, 3, 4. Put the X here. I'll be having X. Sorry, we said X should be bromine. Br. Try to complete this one here. This man here is 1, 2, 3. 1 more makes it 4. 1, 2, 3. 1 more makes it 4. 1, 2, 3, 4. 1, 2, 3, 4. I have this compound. Moving on, plus I have Zn into this. Don't forget, I'm expecting a corresponding answer. By corresponding, I mean if I have 1, 2, 3, 4 carbon here, I must also have not less than 4 carbon and also not more than 4 carbon. So a 4 carbon structure here will give you another 4 carbon structure here. So it becomes something of this nature there. 1, 2, 3, and 4. So I have this. The problem now is now this. We said in our answer here, there should be a double bond. So where exactly do I place the double bond? Listen. The double bond will place in between the 2 carbon bearing the bromine. Listen and listen carefully. In this case, it is this 2 carbon that is bearing the bromine. In my final answer, these 2 carbon must bear the double bond. So hence, double bond will be here. So it means that if this one here was hydrogen and this one here was bromine, in my end result, these 2 are the ones bearing it. So these 2 must not have what there? A double bond. So please be observant. All right. Sorry? But you what there? Like this? They will not be separated. That's a distorted compound. It's not possible logically. So it won't work. So let's say you're saying what if the was here and then the other was here. How do you draw a double bond? Like how now? So the idea will not be that does it exist? Perhaps at your level, don't worry. They won't give you the one that's above this one here. So in your stuff, BR here, H. So these 2 bearing this will now have this. Complete this from having this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Yep, 4. 1, 2, 3, 4 plus Zn. Plus, it said ZnBr2. So Zn, X is bromine, so Br2. In other words, please, which compound is this? 2, 3, dibromo, 1, 2, 3, 4, butane. Okay, this is zinc, of course. What do I have here? 2 butane or both 2 in. And what do you have here? Zinc bromide. So that's how we do this one, please. All right, so let's move on to the next one, please. Number 5, please. The 5th one there is reduction of alkynes. Reduction of alkynes. RC triple bond CR combines H2 slash PB or this Na or this, your product is this R H. For this one, your product is this R H and H. So I have this. What you have here is a cis. This is of course this is a cis compound. You know why it's cis, Abby? Yep. What do you have here? Trans. So you have this. Please. So this is the reduction of alkynes. So here's what it means. Here's what it means, please. There are listen. Here's what it means, please. There are two possible methods of reducing alkynes. Your result is as a product of your reactant. If I'm reducing alkyne using hydrogen or lead or nickel boron, if this one here is what you're using to react with the alkyne, I will have a cis structure of the alkene. Alternatively, the same alkyne, if I use sodium or lithium and what there, ammonia, you have what there, the trans concept. That's the idea. Let's take an example and see how it works. So let's say I have like this. CH3 to C, triple bonded to C, C2H5. Combine this with, let's say, nickel boron. With nickel boron. Please check. What do you think will be your answer? At the same time, write it down. Just write it down. At the same time, let's say I have C2H5 combined with C, triple bonded C. I now had C3H7 combined with lithium or ammonia. Please, for each of these two, please, compare this now. Try to get out the products and name them, please. Get out the products and name them, please. You don't have the luxury of time in the exam, right? So you have to be very smart about this. Here's the thing. This is an alkyne. Watch your reactant. We said when you react with this one here, what do you form there? You form a cis. So my first task is this. Generally carry this one here. So I'm having C1 combined to C2. We said H and H. So here becomes H. Here becomes H. Observe something. Now listen. Perhaps we could call this R1 and R2. Call this R1 and R2. Call this R1 and R2. The idea is this. We said R is an alkyl group. My first alkyl group we said will come here. That's all. In this case here, aside the C here, what is attached to the C is your R1. In other words, this one becomes R1. What do you have here? Methyl. What is attached to this C here is R2. This one here. So what do you have here now? Ethyl. Methyl, ethyl. Simply hijack this and bring it here. So I'm having this R1, there is CH3. So CH3. That's all. R2 here is C2H5. Just come here. We said put R2 here. C2H5. So it becomes C2H5. Draw the complete structure. This is correct. Of course, here is a cis compound. We explained cis and trans in a previous class. So it's a cis compound. Cis what? That's the question. First things first, how many carbon in total? 1, 2, 3, 4, 5. 5 is what there? 10. Please, how do I number? From left this way or from right? I'm going from left because this is 1, 2 as compared to 1, 2, 3. So I'm going this way, 1, 2. So it becomes 6. 6 what there? Pent 2 in or 6 2 pentene. As easy as that. Come here too, same concept. Pick up this one here. Okay, so if I look at this now, I'll just focus on what's the reactant. The reactant now is now lithium and ammonia. And we said if I combine with lithium and ammonia, I'll form the same geometric isomer, but a trans one. In other words, come here, put C double bond to C. Of course, H here. So come here, I'll put H. Come here, I'll put H. Now identify R1 and R2. In this case, obviously this one becomes R1. What is attached to carbon? In this case, obviously, here becomes what there? R2. So as simple as just replace them. That's all. So this one here becomes R1. So I'm having here as this one here. C2H5. Carry R2, bring it here. It becomes C3H7. So how do you name this compound here? First things first. In totality, how many carbon there? 1, 2. 2 carbon here. 3, 4. 4 plus 3 here. How many there? 7. 7 is what there? A hept. If I'm having a hept, how do I number this? Is it from left to right this way or from right to left this way here? It's from left to right. So 1, 2, 3. So because what there? Trans hept 3 in. This should not take you up to 3 minutes. That's your answer. Just carry, paste. That's all. No big deal. Yes, question please. Reactions of alkenes. Reactions of alkenes. So I said, alkenes undergo various reactions. Some of the most important reactions of alkenes include number 1. Some of the most important reactions of alkenes include number 1. Addition reactions. Look at the addition reactions of alkenes. Look at some of the addition reactions of alkenes. Let's take a brief note. No, right, please. Brief note, please. Alkenes undergo various addition. Alkenes undergo various addition reactions, most of which converts them to alkanes, and sometimes alkanols. Most of which converts them to alkanes and sometimes alkanols. Depending on the compound being added. Depending on the compound being added. Depending on the compound being added, some of the addition reactions of alkenes include you have this one here. Number 1, addition of hydrogen. So number one is addition of hydrogen. We've discussed it already before now. We discussed it already before now. So perhaps we can leave it up. So we already discussed it already. Check. Okay, hold on. We discussed it in the last class, Abby. Remember, we'll look at what there formation of what alkanes, Abby. Yeah. So that's it. We said an alkane will combine with hydrogen under what there? What was PT? Platinum. PD, palladium. Ni, to give you what there? An alkane. We discussed in the last class. So just get that note there. Moving on to number 2, addition of halogen. It's called halogenation. So here's your equation of reaction. I have this, an alkene plus halogen X2 to give you this one here. One X will come here, one X will come here, and I'll have this. That's a dihalide. It's more like saying that an alkene will combine with a halogen to give you a dihalide structure. Let's get an example. So you try this. Let's use an alkene. Let's use pent 2-ene combined with let's say chlorine C2 to give you. Can you try to decipher what the answer will be and draw out the structure? So I've given you 2 hints. Pent 2-ene combines with chlorine. What do you think will be the answer? And name the compound. Please try this, please. Get to your work. Let me do mine. Let's see. So the idea will be pent 2-ene. Pent 5 carbon. So 1, 2, 3, 4, 5. For a 2, it means that the double bond is on what there? Carbon 2. So if you choose to call it 1, 2 and put double bond here, you are correct. If you choose to say 1, 2 and put double bond here, you are correct. I want to use this one here. It's the same thing. So this is the 1, 2, 3, 4, 5. Pent 2-ene, 1, 2. Carbon 2 bears the double bond. Complete this. I have this. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Pent 2-ene combines with Cl2, chlorine, to give you what? Of course, to give you a corresponding. By corresponding, I mean the same number of what there? Carbon. So I'm having 1, 2, 3, 4, 5. My first task will be here. Come here. 1, 2, 3, 4, 5. That's my first task. Number 2, observe that when the double bond breaks there, your halogens will attach under the 2 carbons that were bearing the double bond. In this case, it was carbon 2 and 3. These 2 here were the ones bearing the double bond. In other words, my 2Cl, of course we said 2 halogen, so my 2 chlorine will be attached under this and this one. Why? They were the ones bearing double bond. So that means for you, if you are choosing here as your 2, your Cl becomes what there? Here and here. So for mine, it will be these 2, that's this one here. Since these 2 were the ones bearing the double bond, my chlorine comes under here, my chlorine comes under here. Of course, it becomes a single bond. So balance up. I'm having this. 1, 2, 3, 4 complete. 1, 2, 3, 4 complete. 1, 2, 3, 4 complete. 1, 2, 3, and 4. 1, 2, 3, and 4. So that becomes the answer there. How do you know this compound here? This is 1, 2, 3. Becomes 2, 3 dichloropentane. So it's quite simple. Just understand how it works. Right? These 2 will come under the carbon that was bearing the double bond. That's the idea. It's that simple. Take down, please. That's how many now? 2. We're looking at additional reactions of alkenes. We've done 2, this and this. The third one, let's the third one there. The third additional reactions, addition of hydrogen halide. Take down, please. Equation of the reaction is given below. Equation of the reaction is given below. What does this mean? It means that double bond and alkene will react with a hydrogen halide to give you what there? A haloalkane. So this is called haloalkane, or what there? Alkyl halide. Alright, let's get an example. Example. So any alkene at all. Example number 1, any alkene at all, let's say 1, 2, 3. Let's make an alkene. That makes one a double bond there. I'm having, okay, you know what? On your own, no, let's save time. So 1, 2, 3. So 1, 2, 3, 4. 1, 2, 3. 4, 1, 2, 3, 4. So you have this for the alkene plus HX, so plus H. Let's take X as what? What should we use? Let's use X as being iodine. It becomes HI, not high, but hydrogen. HI, what do you call this? Huh? Hydrogen iodine. Hydrogen what there? Iodide. Hydrogen iodide. Bromide, chloride, fluoride, iodide. That's the name. Not iodide though. Like iodide. So look up, please. Look up. Listen. The idea is very simple. See, the idea is simple. For your end product, it will be, look at that place that had double bond. It will break off to single, and then those two carbon atoms that were bearing the double bond, one will take hydrogen, the other takes what there? The iodine. That's all. In other words, my final result will be this: 1, 2, 3. So I'm having 1, 2, 3. That's all. Now I'm having this one here. Observe that it was these two that had double bond. So I said this one will break off to a single bond. These two, one of them will carry the H. One of them will carry what there? The iodine. That's all. That's all. Now complete this. 1, 2, 3, 4. 1, 2. Connect these two first. So 1, 2, 3, 4. 1, 2, 3, 4. That's all. How do you call this, please? It's called 1-iodo-propane. 1-iodo-propane or no. Please. 1-iodo-propane. This is called a propene. I've told you why it's propene, not necessarily prop 1 in. Because there's no prop 2 in. So prop 1 in, propene, so I have this. There is something peculiar about this reaction. This is one of the most important reactions, so please add an asterisk to this one too. Take that, please. The reaction above is called Markovnikov's addition. The reaction above is called Markovnikov's addition. Please take note of this. I'll take to note two things. Last class I said what there? Grignard reagent. Now I'm telling you to note Markovnikov. Listen. Someone is asking, listen. See the difference between equation of reaction and then example reaction. In equation of reaction, I left these ones here without putting H. Why? Because they can be continued. So observe that in this one I had 2 carbon. In my example I have what there? 3 carbon. I continued it. That's why I left it this way here. But if you're doing an example like this one, please do not leave it blank. Please. Because if you submit to me like this, you now leave it blank and submit to me. No, just go and find blue pen and put here and continue for you. So please complete it. Yes. Now listen. Why is it called Markovnikov? Please take that, please. Markovnikov's addition. So let me define this. I said it's one of the most important. So let me define it, please. Markovnikov's addition involves the reaction. Markovnikov's addition involves the reaction of an alkene with a hydrogen halide to produce an alkyl halide in brackets haloalkane. I've said they mean the same thing. I've explained before. Markovnikov's addition is the reaction of an alkene with hydrogen halide to produce an alkyl halide in brackets haloalkane. Please add there, in the absence of a peroxide. In the absence of a peroxide. In the absence of a peroxide. Full stop. When a peroxide is included, the reaction is called anti-Markovnikov's reaction. When a peroxide is included, the reaction is called an anti-Markovnikov's reaction. Anti, A-N-T-I. What you call anti? It's not anti. It's anti. It's not anti. That's not anti. It's not antichrist. It's anti-Christ. It's anti. So look up. Look up. I am saying this. What you have here is a Markovnikov's addition. For anti-Markovnikov, it is exactly the same thing. The difference is that I'll add what there? A peroxide, H2O2. This one here becomes what there? An anti-Markovnikov. So that's it, please. Difference between Markovnikov and anti-Markovnikov is the presence of what there? A peroxide. The popular peroxide includes this one here, hydrogen peroxide, this one here, sodium peroxide, this one here, barium peroxide. So these are some of the peroxide you can use. That's it. That's it. Let's proceed, please. Next one there, please. The addition of water. This is called hydration. Dehydration of alkenes. Dehydration of alkenes results in the formations of alcohols. Dehydration of alkenes results in the formation of alcohols. Results in the formation of alcohols. Of alcohols. Let me give you a task. Use both 2 in and your initiative form a reaction for this. Use both 2 in as your alkene, add it to water and see if you can get your product here, please. That's your task. Use both 2 in, combine with water and see if you can get your product. Let's get it done. Both 2 in, both 4 carbon, 1, 2, 3, 4. By 2 in, it means double bond is on carbon 2. Count this way, 1, 2, like this. Count this way, 1, 2, same thing. Complete this, I have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's both 2 in. Combine this with water, H2O, and hydrogen ion, H+. What do you get? We said you have a corresponding. So by corresponding, I have 1, 2, 3, 4. I have 1, 2, 3, 4. Observe that in the corresponding, they are singly bonded in quotes or single bonded. That means it has to be a single bonding. The idea will now be this. Right, OH. That means the 2 carbon bearing the double bond, one of them will take H, the other OH. So these 2 were the ones bearing the double bond. One of these will take H, the other OH. Complete the structure. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So if I should name this, it becomes 1, 2. It becomes 2 butanol or butan-2-ol. So butan-2-ol. This is what you get majorly. And I said there's a minor product. What's your minor product? Check very well. How many oxygen? 1. How many hydrogen total? Okay, how many carbon? 1, 2, 3, 4. 4, that's complete. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this one, 11. How many here? 1, 2, 3. Is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 now. Here I'm having, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Abi? What again there? Plus what there? Plus H. So you see why, hold on, you now see why they didn't add the H there. Of course, H is not really that important. So I'm taking it off. So that's why they didn't put the H there. It left like this. But we informed that the hydrogen ion acts probably as a catalyst here. So I have butan-2-ol. Next up, please. E. Next up, please. E. E. Halohydrin formation. This involves adding an alkene. This involves adding an alkene to a halogen. It involves adding an alkene to a halogen and water. It involves adding a halogen, an alkene, please, to a halogen and water, resulting in the formation of a haloalkanol, and hydrogen halide, resulting in the formation of a haloalkanol and hydrogen halide. So see if you can get out the equation of the reaction on your own. Okay, should I do it? Please try, please. Now listen. Here's how it's done. Please, what's the first thing there? Okay, before then, how many reactants do I have there? 3. What's the first thing there? Observe that alkene, we always use what there? 2. Abi? Yes, when we use 2 carbon, it's also like this. 1, 2. This. It's always like this. Alkene plus what there? Please, your halogen, it's X, Abi? Yes. Is it X or X2? It's X2. That's why she missed it out. That's something she missed because she wrote X, so it's correct. Why? Because halogens are what there? Diatomic. So it cannot be X, it's X2. So it becomes plus X2. Halogens are diatomic. Next up, plus water. There's no way you don't know water now. So plus what there? H2O. To give you what there? When you hear the word halo and alkanol, it means an alkanol that has what there? A halogen. Don't forget, we are maintaining the same 2. So it becomes something of this nature here. Yeah? 1, 2. An alkanol has to have an OH. When we now say haloalkanol, that means this man also have what there? A halogen. So come here and put what there? X, not Cl. X. And then this. Plus what there? Hydrogen halide. H and what there? X. Very simple. Very simple. Please use hex 3 in. See if you can form a complete compound. Name your major compounds. Use X. Use X as chlorine. Use X as chlorine. Use hex 3 in. See if you can form a complete equation of reaction. Then name your major compounds there. So look up. The stuff is simple. What's the first? Look up. Look up. Hex. How many carbon there? So I'm having 1, 2, 3, 4, 5, 6. They say hex 3 in. To carbon 3, 1, 2, 3, add double bond. That's hex 3 in. Complete the structure. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Hex 3 in. Combines with, we said X should be what there? Chlorine. So it becomes what there? Cl2. Plus what there? Water. That becomes what there? H2O. To give you what? First of all, is a corresponding. So get number of carbon there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have this. What next? I've said this over and over and over again. Observe that in your answer is not X and X. Maybe you give me X and X. It's not die. It's X and OH. That means those carbon bearing the double bond, one of them takes X, the other one takes what there? OH. That's it. So which of these two bears there? This and this. So this the third one here. The third one takes what there? Cl. That's X. The other one takes what there? OH. Very simple something. OH. Now balance up here. I'm having H, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Some of you missed out on the naming. But I don't blame you though, because we've not done alcohols yet. So I don't blame you though. But listen, when it comes to this, when it comes to, see, the idea of taking substituent as priority is only for alkenes. For alkenes, your double bond is the priority. For alkynes, the triple bond is the priority. For alcohols, the OH is your priority. In other words, I will name this in such a way that the OH becomes what there? The smaller number. If I name this left to right, I'm having 1, 2, 3, 4. Carbon 4 bears OH. Name it right to left, I'm having what there? 1, 2, 3. Carbon 3 bears OH. That's the smallest one. So my number becomes 1, 2, 3, 4, 5, 6. So that's the OH. So I'm taking the OH over the chlorine. That's the idea. So name this. What do you have here? Yes. So you are giving me 3 chloro, 4. No, it's 4 chloro. All right. So I'm having 4 chloro, 3 hexanol, or 4 chloro hexan 3 all. That's not all. I'm still left with what there? Plus HCl. Very simple something there. It's simple. Just use your eyes. That's all. Let's proceed. Number what now? F. Okay, so number 6, F, is called hydroxylation. Hydroxylation, also called glycol formation. It's called glycol formation. Okay, take down please. Let me see if you can try to form the equation of the reaction. Take down. It involves the reaction of an alkene with permanganate. It involves the reaction of alkene with permanganate. You know what permanganate is, Nabi? Yes. If you don't know, you didn't do chemistry practical. It's in your practical manual. Abi? Yes. Yes, it's there. It's there. All right. It involves the reaction of an alkene with permanganate. By the way, permanganate is what there? KMnO4. Under the influence of performic acid. Under the influence of performic acid, this way, this is called performic acid. Under the influence of performic acid, to form a diol. Under the influence of performic acid, that's this, to form a diol. When I say under the influence, what does it mean? Catalyst. So see if you can get out equation of this reaction. Form the general equation of the reaction. To form a diol, diol. See if you can form the general equation of the reaction, please. Are we done? Tell me what you have there, please. What do you have there? Tell me you have alkene. Give me structure. What do you have? C double bond what there? 1, 2, 3, 4. Abi? Combine with what there? KMNO4. Permanganate. Under the influence of what? That becomes what there? HCO2OH. To give you what there? What will that all be? C, yeah, OH, yeah, OH. This. So if you do this, you're correct. That's it. No, stop here. So do me this. Try this. Take propanol or take propene. Fine. Use propene. Draw out a balance or draw the equation. Use propene. See if you can listen there. Use propene. Draw out a reaction for this. Using propene, please. All right. So look up. So I've said prop-in or prop-1 in. There's no 2 in. So propene is always prop-1 in. They're the same thing because there's no prop-2 in. I've explained that before. So for prop, 3 carbon, 1, 2, 3. Put double bond. Let's say here. So balance it up. I'm having 1, 2, 3, 4. 1, 2, 3, and 4. 1, 2, 3, and 4. That's this. Combine this man with potassium permanganate. Okay, under the influence of performic acid to give you a diol. Don't forget, we said the 2OH will come under what there? The carbon bearing what there? The double bond. So 1, 2, 3. I'm having 1, 2, 3. These two. This one here, OH. This one here, OH. Balance up. Single bond, 1, 2, 3, 4. 1, 2, 3, and 4. 1, 2, 3, 4. Please name this compound. What have you got? 1, 2, propan diol or propan 1,2-diol. That's the name. Prop 3 carbon. So my number will now be 1, 2, 3. So 1, 2, 3. That's your prop. It's going to be a propanol, but there are 2 or. So because what there? A diol. So I'm having 1, 2 propan diol or propan 1, 2-diol. This is the end of addition reaction. We have 2 more types still under alkene. We have substitution. We have another one again. All right. We are still under reactions of alkenes. Number 2 is substitution reaction. Take that, please. Number 2, substitution reaction. Number 1, under this you have halogenation. Under this you have halogenation. Is also called allylic substitution. It's called allylic substitution. Take down these notes. Unlike the addition type, okay, hold on. Unlike the addition reaction type, Unlike the addition reaction type of halogenation, comma, this one involves the use of heat, H-E-A-T. This one involves, please, the use of heat, resulting in the displacement of one hydrogen atom. This one involves the use of heat, resulting in the displacement of one hydrogen atom by an atom of the halogen. So let me give you a hint. Let me give you a hint, please. So can you look at that stuff and try to figure out what the general equation will look like? Look at the video, please. Look at that stuff. Try to figure out what the general equation will look like, please. You have 2 minutes, please. For time's sake, please. Alkene, this 1, 2, this 1, 2, 3, 4. Alkene plus what there? Halogen, X2, diatomic. Under what's there? Heat. Not just heat, but also low concentration of the thing there. So plus low concentration give you what there? Now listen, you now have this 1, 2, X, and then this. Now listen. Before your test, I will show you another dimension of organic chemistry. I can't show everything at once. I'll take it in bits so you get it. But listen, in general, there are 3 types of reactions that organic compounds undergo. The first one is addition. The second one is substitution. The third one is elimination. The difference between addition and substitution is this. If there's an addition, a triple bond breaks to a double bond. For an addition, a double bond breaks to what there? A single bond. That's addition. For a substitution, the word there says substitute. If I have 11 players on a field and I substitute, how many players will be on the field there? Yeah. Still 11, no matter how many changes there. So the idea is this: if I'm having a double bond and it is undergoing substitution, it will not break down to an alkane. It will still be what there? An alkene. So that's the difference between the addition and substitution. For addition halogenation, go and check. This man broke down to what there? An alkane. Go and check. Why for substitution? It doesn't break down. Difference is that the hydrogen here will be displaced by what there? One of these. And of course, plus HX plus HX. That will be your last thing there. That's how it looks like. Take 18. Take X as bromine. Get out a complete equation, please. Take 18. Take X as bromine. Get out a reaction. That should be simple now, right? Yes. Yep. That's 1, 2, 1, 2, 1, 2. 18 plus Br2. So X is now Br. So Br2 under heat and of course low concentration to give you 1, 2. Observe that one of these will now be displaced by what there? Br. Observe this. I now have H. One of the H will pick up one of Br plus H Br. So I have this. This is what happens, please. Alright? Just displacement of this. I have this. 18 bromine. What do you call this, please? Huh? What do you call this? Someone was telling me 2 bromo. Please be careful. It can't be 2 bromo. Don't go and say, listen. People make this confusion. You not go and say, okay, this one has double bond, so 1, 2. No. Actually, before you start numbering, check both sides. If I count from both sides, I have 1 carbon before double bond, 1 carbon before double bond. In the case where you have the same number in both sides, the double bond is no longer what there. The priority. Shift your focus to what there. Substituent. If I shift my focus, it becomes this one here. So this is 1, this is 2. It becomes what there? 2, 1 bromo at there's no at 2 in, all right? So 1 bromo at 10. That's it. Or bromo at 10, yes. Because there can be no 2 bromo, abi? There can be no, so you can say better still, yeah. Bromo at 10, because there can be no 2 bromo at 10. And then hydrogen bromide. That's it. That's your equation. Yes. Yes. The third type of reaction is called cleavage reaction. Cleavage reaction. Under cleavage reaction, look at what's called ozonolysis. Please, another important one, please. Give an asterisk there. Another important one, please. Ozonolysis. Yeah, that one is another concept. Not under this one. What is ozonolysis? Take down. This involves the addition of ozone. This involves the addition of ozone to an alkene. This involves the addition of ozone to an alkene resulting in the formation of an ozonide. Resulting in the formation of an ozonide. Ozonide. O-Z-O-N-I-D-E. Ozonide. Which on further reaction with zinc dust and water, which on further reaction with zinc dust and water results in the production of an aldehyde on the board, an aldehyde and ketone. This ozone combines with an alkene to give you an ozonide, which reacts with water and zinc dust to give you what there? An aldehyde and a ketone. Equation of reaction, please. Equation of reaction, please. Don't worry, you won't get that one. Don't worry, just look up. Let me help you. Don't stress. You won't get that one. Look up. Let me help you. For ozone, what's your chemical formula for ozone? O3. O3. When did you know it was O3? When did you know? I knew that ozone was O3 in my GSS2. GSS2. Not senior secondary, junior secondary. And it was a weird way of, I knew it in a very weird way. A very, very weird way. Right? So here's how it happened that I think that was the test. We had taught about this, what's it called? Ozone layer depletion. So he taught us ozone, but I didn't take note of it. But I remember that he gave us OZ, something like that, in the note. So he gave us a test. In the test, he now gave us, write the formula for ozone. I remember it was OZ. So I just went and wrote OZ. as you'd expect, they give us the answer sheet later, and I saw it wrong there. Right? And I was like, why is OZ? I think it's OZ. So OZ was wrong. So what did I do? I was like, okay, no problem. I would revise it before exam. Somehow, I landed in the exam hall, and when I was entering, my mom was like, Ingo said that same question, no? Go read down. I had it in mind to study, but I don't know how. I didn't just study it. I entered the exam hall. He now said the same thing again. And you know, what's painful is that you fail a question in test, you say you will learn it, you now sit again, and you're still going to fail it again. Right? It's not like if I didn't, like, I said I would learn it, but I just don't know. It just kept my mind. So what did I do? I was like, okay, so in test, I wrote OZ, and he marked me wrong. What do I do now? I said, so I did this. I said, okay, O. So I don't went back to alphabet. I said capital letter A, small letter A, capital Z, small letter Z. I'm telling you, I'm telling you. So I said, since I use capital letter, let me now use small letter. So it's a right symbol. I wrote O. In my mind, I wrote Z. I just did this. And I submitted. They now submitted, hold on. They now gave us script, right? And you know, I was pained. Honestly, I was pained that I'm seeing that I was pained that I was going to fill the question again. But it's like, let me just write something, right? So give us the sheet there to come and like you're collecting sheet, answer sheet that day. And I looked at the question, it was not correct. I was like, I got something. So I took the paper there. I went to my teacher. And I was like, sir, look at this thing now. I got it in test. You marked me wrong. But that is correct. The man now say, come. What did you write? Is this not O3 is correct? Oh what? O3. Okay, yes, it is correct. It's correct. And that's how I'm telling you. That's how I left that place. Since that day, that was this S2. I think second term also. I never forgot it. So I was writing Z, he was thinking 3. So since that day, crazy thing like this. If there's one lesson I picked up from that experience, is to always write something in exam, even if you're not sure. Instead of leave it blank, write nonsense and leave it. Especially if your nonsense has a very good handwriting. Don't give +1, +2 there. It's something. That's why I'm not a fan of writing something empty sheet. See, you don't know the question, no problem. Write something. You're not sure of it, no problem. Write something and submit. All right, this man plus O3, ozone, to give you ozonide. Ozonide is, please look at something below. See how ozonide looks like. Ozonide is this. C, this O. This stuff came out last year too. Please take note. This will now say combine. Okay, you know what? For reference sake, let me take this man higher. Let me take it up, please. Let me take it up so I'll have space downwards. This one will block all the space here. So please, sorry, excuse me. All right, so you have this, please. This is your aldehyde. This is aldehyde. This is your oxonide. Ketone. That's your ketone. This one here is your ozonide. Now listen, let me show you how this works. Look up, please. Let me show you how ozonolysis works, please. Look up, please. So listen, don't forget the reaction is this: alkene, ozone, ozonide, zinc and water, zinc dust and water, aldehyde and ketone. That's your series. Listen, this is how your ozonide is formed. Listen. For the ozonide, first of all, take up this form. If I take up this form, I have something like this. I'm having something like this. Look up, please. I'm having this. This one first. I'm having to give you. Look up, please. I'm having C. This one here. This one here. These two meeting up here. Now listen. This is how the ozonide is formed. When you have your double bond, it will break off into two. When you have your double bond, it will break off into two. That two now, the left side, like this, will take this part here. The right side will take the other part there. In other words, if this breaks, CH2, this CH2 will appear here to become CH2. That's how it's done. That one is balanced. This is having C 1, 2, 3, 4. It will automatically balance. The part on the left side to hijack it, bring it here. The C you see here is this connecting one here. So C is this connecting one. This one connects one there. H. So it becomes 1, 2, 3. The first one becomes the this alkyl group. CH3, CH2. In other words, for your ozonide, the simplest explanation is this. Hijack this one, bring it here. From double bond, hijack this one, bring it here. It's called an ozonide. That's all. Huh? It's an alkene now. It cannot be single bond. This is ozonide. So that's how it's done. When you have double bond, break it into two. That's it. I'm coming. Into what's there? H2O and Zn. To give you, listen up, look again, listen up. Listen up, oh. This same thing will still come to play again. C, I'm having C connected to O. Now listen, this C has one hydrogen. This H takes one part up. I'm having H up. The other alkyl group gets fixed here. So it becomes CH3, CH2. Please see the same thing. CH3, CH2 fixed here. This H goes up. Then this one here, O2, this one here. Plus, what would this one be? O like this into C. Abi? How many H there? So I'm having these two. You know how it should look like? One here, one here. That's it. This compound is called a methanol. I will tell you why it's called methanol when we look at the aldehyde and the ketone. This one here is called a propanol. There is propanol, there's propanone, there's methanol. Look at these ones much more later. But I'll tell you why it's called this one. So that's the name of this. That's what it's called. All right, so this is all about the alkenes. That's all about the alkenes, please.